All right. So what we're learning, what we're doing for the next 2 days is law of sines and law of cosines. Okay. The purpose for these two, they're formulas, although they call them laws. The purpose for these formulas, they're used for finding a missing side or angle of a triangle without a right angle. Okay, so at this point, you've learned other methods. We started a little ways back with the Pythagorean theorem that you could find a missing side if you knew 2 of the others, but that was for a right triangle. And then we learned trig, which allowed us to find missing side lengths and the special right triangle ratios. But again, all of those things are built on right triangles. So there's a method that comes into play if we don't have right triangles, if we have the right pieces of information in a non-right triangle. Okay, so these 2 laws are 2 formulas that some nice people derived so you don't have to do as much work, and they use sine and cosine, so they do use trig, but they have figured out that piecing the information together in these formulas gave us the missing side lengths or angle measures that we need. One of the first things to know, and I don't want you to get caught up with these labels, they're there as a reference, but what we talked about with the area formula, where angle A is across from big A is across from little a, big B is across from little b, and big C is across from little c. Don't get all anxious if your triangles are labeled differently. The biggest thing in the formula, especially if you notice the law of cosines, that the little side has to be by itself across from the angle that's included in the formula. That's the biggest thing that you're going to look for, okay? The other thing I want to point out is law of sines looks pretty complicated. You have a number of things equal to each other, but you're not going to use all of this at once. Basically, our goal is to set up a proportion, so you might just use that, okay? A proportion is actually what we're doing with the law of sines. Now, if you're more comfortable putting the sine of the angle on top as opposed to the bottom, as long as it's on top for both halves of the proportion, that's fine. So the sine of the angle for that is either going to be both on top or both on the bottom, all right? The other thing I want you to do, because I don't like the way that this is set up, is it appears that it's the sine of a side. We don't take sines of sides. So I want you to quickly go through and make those sine of an uppercase A, all right? So this should be uppercase, 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 and the same thing over here, because we only take the sine of angle measures. Okay, so this actual sheet came from a good sized packet of stuff that we're not going to do all of that. It's something that I found online that is quite handy, you know, in getting you to see how the formula is used. The first thing I want you to look at is law of cosines is the best choice. They get into a little bit more detail, but if the length of all 3 sides are known and you're finding an angle, or if 2 sides, the enclosed angle, and the third side basically what that boils down to and really what you need to be looking at, so in the margin over here, is if you are dealing with 3 sides and 1 angle, one of which of these would be unknown, okay, but it's still 3 sides and an angle, then you're dealing with cosines. And you can see in the picture, I have 3 sides and 1 angle. Here, I'm dealing with 3 sides and 1 angle. Those are law of cosine situations, okay? And if you look up at the formula, you should see 1, 2, 3 sides and 1 angle. B and C are just a repetition of the sides that you already were using. But 3 sides, 1 angle, you've got law of cosines, okay? Now if we switch down to law of sines, they're talking about 2 sides and angle opposite of one of those is known and you're trying to find the other. To make this a little bit easier to understand, look back up at the formula. I said that you're probably only going to use one proportion. That is 2 sides and 2 angles, right? 2 sides, 2 angles. If that's what you have, you're able to use law of sines. So over in the margin here, we want to note that this is for 2 sides and 2 angles, one of which would be unknown. Now, for me, and if you're a more visual person, there's actually a visual that I use to determine what goes into which part of the formula. And if you look back up at the formula for the law of cosines, which is where we're going to start, you'll notice that side A is at the beginning of the formula, angle A is at the end, and that's the only place where those 2 pieces appear in the formula. So if I look at this, this diagram, okay, I need a side and its opposite angle. So the rest doesn't matter because you're going to square it and you're going to multiply it. So kind of like the area formula using sine, the B and C don't really matter. It's the side and the opposite angle that we have that you have to plug in correctly. So when you look at this, do you guys see a T of sorts? I mean, they didn't put the sides quite in the middle, but when you have a side angle side, and then with the opposite side of the angle, it makes kind of a T. That's law of cosines, because you have 3 sides and 1 angle in between. So what I want you to do is circle the angle on the opposite side. Those are going to be your A's. B and C don't matter. Okay? So what we're going to do, we're not going to solve today. We're going to actually save the algebra for tomorrow. We're going to plug in today, though, so you can see how it's plugged in. All right, so if you look up here, the side that you've circled goes by itself. So in this case, that's 5. So you're going to do 5 squared equals, now we go to the other 2 sides, and it's going to feel a little bit like the Pythagorean theorem in a way, because you're going to do 5 squared equals 7 squared plus 12 squared. Either order, it doesn't matter. Minus 2 times what you just used. 2 times 7 times 12. So the B and C sides are like your middle matter. They go in the middle, either order, as long as you have each of them here and each of them there. And then we end it with the sign of the angle that you circled. So it'd be the sign of x.
So where do you get 2 from?
It's part of the formula. Kind of like in the quadratic formula, there's a b squared minus 4ac. That negative 4 is always in it. It's just part of the formula.
Got it.
Okay? But, so you guys understand what I'm saying? Whatever you circled is the first and the last, and then the b and c are the middle stuff.
Wait, isn't the cosine?
Oh, yes, sorry. Yes. Cosine. My bad. Yeah, thank you. Of course, it'd be law of cosines, right? Yep, should be cosine. Sorry about that. Okay. So, now that you've seen how I did it here, I want you to take a second with this diagram, because that is also law of cosines, and see if you can get everything plugged in the right places. I will say with law of cosines, if you're trying to find the angle measure, it's some pretty involved algebra. It's probably the worst case scenario because you've got to get rid of everything else to get that. And then you have to do the inverse cosine on each side. So it's pretty ugly. But it's kind of like the quadratic formula. Once you learn the steps to get it by itself, then it's the same thing every time. Okay. So if you haven't already, take a second, see if you can plug stuff in the right spot. All right, so hopefully you circled 87 and x. Now, if my angle were over here, obviously it wouldn't be the top and bottom pieces I'd be circling, right? You always want to circle the middle of the T, so to speak, or you want to circle the angle on the opposite side because those are your A's. Okay? So what do I put first, 87 or x? Yeah, x squared, because you do the side squared, okay, equals, now these are your B and C, doesn't really matter where they go, 13 squared plus 24 squared, minus 2 times 13 times 24, times cosine of the angle. Okay, and the rest will be tomorrow, which is the algebra to clean this all up. All right, so that's law of cosines, just the plug-in. Today you're just going to plug in, and you probably will have time before we go, once we talk about sines.
Can we start now? We have 2 minutes.
We haven't talked about sines yet. Okay. Guys? All right. So law of sines, here's what I want you to do. If you do not have 3 sides, your option is law of sines, okay? And what you're going to do is you're going to circle each angle with its opposite side, okay? So this is an easy one. That's easy to see. 49 is opposite of angle, the angle that's 115. This one's a little bit, but those are opposites, right? So you're going to make an X out of them, opposite side to the opposite angle. Here we have everything we need except that. You can do the sine of the angle on top or the sine of the angle on the bottom, but you've got to be consistent. I usually do them on the top because it's the law of sines. So you would do the sine of 115 over 49 equals the sine of x over 16. And in all 3 of these, you should only have 1 unknown. If you have more than 1 unknown, you're missing something, okay? Again, we're going to talk about how to solve this tomorrow. Case 4 is slightly different. Not much, but if I go to the angle with its opposite side here, that would be 22 and 15, right? Okay. So those 2 go together. But do 48 and x go together?
No.
They don't. You don't want to introduce a new variable here. You want to use, we have to have 2 sides, 2 angles. So we have to use x. The problem is we need the other angle. Can you find it?
Yeah.
Yeah, you can find it. 48 and 22 add up to 70. 180 minus 70 is 110. So this angle is 110. That way we can circle that. So if you're missing an angle and you've got 2 out of 3, then just find the other angle. So we would do sine of 110 over x equals what?
Sine of 22 over 15.
Exactly. Okay.
Yeah, this is easy.
Wait till you get to the algebra.
No way. I knew you were gonna say that.
Some of the algebra, the sign algebra is not so bad, because if you have the sign of a number, I just turn it into a decimal. And then, so these would both be decimals, and then cross multiply and solve for x. But law of cosines gets a little iffy, all right? So, what you're going to do is exactly what we just did on the examples on the previous page. Notice each of these say do not solve. You're not going to solve today. I don't want to get into the whole algebra thing today. What you're going to do is determine would you use sines or cosines, and then you're going to plug the numbers into the appropriate formula. Okay, so right off the bat, what are you thinking you should use here? Do you have 3 sides or 2? 2, so it's got to be sines, right? So if we're plugging in, make your little x, circle your opposites.
If it's only one, then it's cos.
If you only have 2 sides, it's sine. If you're dealing with all 3, even if one of them's unknown, then it's cosine.
Wait, what?
Okay, if you only, here, I only have 2 sides, the third one is an even, 2 sides would be sine. 3 sides, like this one, all 3, it's going to be cosine. Alright, so guys, you're still plugging in. So this would be what? Sine of
112 over 125
equals,
x over 12.
okay, so all you're doing is plugging in.
I like this one.
Okay, over here, so we'll do number 2 together. Sines or cosines? You have 3 sides, so it'd be cosines. So remember, look at your T, you're going to circle the angle with the opposite side for cosines. This is your first and your last, right? What goes first, the side or the angle? The side. X squared equals, then you're going to do your B and C. 16 squared plus 15 squared. Minus 2 times the same 2 things you just wrote. Minus the squared. 2 times 16 times 15. Law of cosines. So do cosine of 87. Okay. So you only have the remaining 4 to decide which law and plug in your stuff. And again, if you feel like you don't have enough, remember, 2 sides is automatically sines. If you're missing an angle, you probably already have 2 of the angles. Find the third one. Okay. You're hang on to it till tomorrow. Go to YouTube and then search under LRI, and all of the steps will come up, and you might have to sit through geometry. One entire page. These are sides, so they don't actually give you a variable, but I would go ahead and say, okay, JM, I'd put a variable in, okay, and then say, okay, I've got two sides equals, that's clearly sine. So I think this whole side will be sine, and this whole side will be cosine. So, yeah. So, sine, cosine, and then as far as the algebra, I'm gonna.
Oh, I forget.
Yep.